Okay, in this short lecture, we are going to discuss how to draw Mohr circle using the McClintock's approach, which will guide you on how to draw Mohr circle from strain rosette readings. Okay, let's say we have this strain rosette here, A, B, and C. A is in the direction of X, B is 60 degrees counterclockwise, and B and C is 120 degrees counterclockwise. And the readings for the strains at A is 60 microns, at B is 135 microns, and at C is 264 microns. Let's just put a value there. So what we do, of course, you have to use drawing tools and graph paper. Okay, you must have drawing tools uh, and graph paper to do this. So what you do first is, now if we look at our strain readings here, they are all positive, right? Because they are all positive, then we put our reference vertical axis close to the left of your graph paper. Maybe your graph paper is until there, right? So we put it somewhere to the left of the graph paper. Then towards the top, we draw a horizontal axis. Now this is just a reference axis. It's not the final axis yet. Both of them will be initial reference axis. Okay, so the horizontal axis will be a normal strain epsilon, and the vertical axis will be gamma over 2, or the shear stress, shear strain. Okay, then we mark using scale. Of course, you have to use scale, use proper scaling, right? And we mark the point for strain A, strain B, and strain C, 60 microns, 135 microns, and 264 microns, and draw vertical lines through the 3 points. So here you have strain A, this is strain B, and this is strain C, right? So from the points we draw vertical lines. Okay, now what do we do next? Next, we take a look. Now, the middle line between the three of these lines is B. So, B is in the middle. So, what we do then is, we look at B. Now, B is 60-degree clockwise, you go to A. 60-degree counterclockwise, you go to C. So, the difference is 60 degrees. So, what we do is, we find an arbitrary point along the line, vertical line through B. Any point. Okay, so what we do is, from that point we draw two lines. 60 degrees clockwise from B we draw one line, and 60 degree counterclockwise from B we draw another line. So remember, clockwise from B is A. So we draw the line until it intersects the line through A at point A here. Okay, when it intersects, that point is point A. And for the line which is counterclockwise, we draw a straight line until it intersects the line from C, the vertical line. And that will give us the point C. Okay? Then we find the centroid of each line, AB and BC, find the centroid. And from the centroid, draw perpendicular lines. So you have two perpendicular lines, one between AB and one from center of BC, until they intersect at point which we call point C, right? So point C now is the center of the circle, center of Mohr circle. So we have point C there, right? So what we do is, we draw a horizontal line, and that is the new axis for the normal strain. through point C. So here is now our origin for our Mohr circle. Here is point C, the centroid of the circle, and the horizontal line is our new axis. Don't worry about this one, you can always stretch it down until whatever value you want. Then from point C, point C here, the centroid, okay, to point C on the initial line, or from point C here to point A, so you can also use this here, that is also R, meaning they are the radius of the circle. So using your drawing tool with this point as the centroid and R, you draw the circle, so you can get a circle, right? And that circle is your Mohr circle for this problem here. And from there, you can get the principal strain, strain 1 and strain 2. You can also get location of the x-axis. Remember, the x-axis is in the direction of A, okay? And that is x. Therefore, if you draw a line from A, right? This line here, let me find that's point A there, and that's point C. So I need to draw a straight line there. Okay, something like that. That line represents the x-axis. Okay, point A represent the x-axis, right? So if you want to find strain on the x-axis, find coordinate of point A. And if you extend it over here, you'll get point Y, right? You get the Y coordinate will be normal strain Y, gamma over 2 xy. So now we know that on the y plane, you have positive, and on the x plane, you have a negative normal shear strain, because the coordinate here will be strain x gamma over 2 xy, and it is negative, right? It is above the origin. Below here it is positive. So if you have your strain element x and y, and you have your strain element, right? So now you know that strain at point A is smaller than strain for y. Therefore, this increases, right? It increases just slightly. So that distance there is strain x dx. Okay. While on the y, it increases quite a big amount. So that value then is strain y dy, right? Now the angle, now remember our reference is x, and x is negative, meaning on the x, the angle gets larger. So the y also it gets larger. Okay. Sorry about my lines. They are not very good. Okay. Okay. So we have something like that, right? Until it intersects that line, and this one intersects that line. So you draw parallel lines from both points, so you have something like this and something like that, right? So that is the deformed shape. So you draw using your tools, you can get a better shape than what I did. Okay, and that is how you get Mohr circle direct from readings of a strain gauge with 3 elements. Okay, uh, three strain gauges from a strain rosette. Have fun practicing.